Hello dears, good morning to all. How are you dear children? I hope you are all fine. Please take much care in this pandemic situation. So dears, today we are going to start a new chapter. Before starting the chapter, let me show you some images. You have to observe it carefully and observe each one among them and find what are they doing. So the images for you are here. So dear students, I hope you have visualized the images very well. So what are they doing in those images? Okay, in it a person is making an axe. Okay, then a boy performs an experiment. A boy performs an experiment. A boy performs an experiment. Then something else. Okay. A man cracks a cracker. A man cracks a cracker. And finally, what you have been seeing? Yes, of course, a woman prepares food. A woman prepares food. Okay. Yes. In all these situations, actually what happens? A change has occurred. Am I right? Yes. In this case, when the person is making an axe, he uses wood. So he transforms a wood into an axe. So a change occurs. What about in this boy's case? He is performing some experiment, whatever it is. He is performing an experiment. So performing an experiment means, as you all already knew, that he is transferring some compounds into something else. So there too a change occurs. And what about in this situation? You have already familiar with cracker and you have already used it in your life. So a man burns a cracker, means burning a cracker. The cracker has changed to something. And finally a woman prepares food. What happens here? He uses a rice for the preparation of food. And after the preparation, will rice be in that pot or food will be in there? Of course, food will be there. So there too a change occurs. So in our daily life, in our surroundings, in the nature, we can encounter a variety of changes. And these changes are of two types, as we have mentioned here. Let us consider this case. There, that woman transferred rice into food. So what happened there is that the food is something else from the rice. So the property of rice and the properties of the food are not the same. Rice and food are two different compounds, which means the change occurred in there is a chemical change. A chemical change means there occurs a complete transfer of the compounds. a new compound is formed, a new product is formed. So apart from rice, the new compound formed here, the food, is something different. So both the rice and the food formed are of two categories. That's why we mentioned it as a chemical change. So whenever a chemical change has occurred, a compound has completely transferred into something else. As just like in this situation, in the case of a cracker, initially it was a cracker, but after burning it, it has transferred into something else, some ash, some powder, something else. And in the case of that experiment too, whatever be the experiment he has performed, he has transferred a chemical compound into another chemical compound, which means all these three processes are composed of a chemical change, So in a chemical change, the property, the nature, the characteristics of the compounds are completely changed. Then what happens in this first case? When that man prepares an axe from wood, is there any change in the property of the wood and the axe? No, both wood and the axe are same compounds, because nothing has chemically changed in that case. Only the physical appearance has changed, only the physical shape has changed, and nothing chemically has changed there, which means here the change is a physical change. Here the change occurred is a physical change. So we know that changes are of two types. One is physical change and another one is a chemical change. So changes are of two types, physical change and also a chemical change. So let us consider some more chemical changes. So before that, I am going to divide you into 4 different groups: group A, group B and group C, and finally group D. So let me give you a reaction between hydrogen and chlorine. So the reaction between hydrogen and chlorine. So hydrogen and chlorine, they are combining with each other. Okay, so let us consider 2 cases. In the first case, the mass of hydrogen is 2 gram. The mass of hydrogen is 2 gram and the mass of chlorine is 71 gram. And in the second case, the mass of hydrogen is 4 gram. The mass of hydrogen is 4 gram and the mass of chlorine is 142 gram. The product formed here is nothing but hydrochloric acid, or simply HCl. HCl is the product formed here, and in the first case the mass of HCl obtained is 73 gram. The mass of hydrogen obtained is 73 gram, and in the second case the mass of HCl obtained is 146 gram. So dears, consider these 2 experiments, experiment number 1 and experiment number 2. Now you have to write on your notebook, in the first experiment, what are the reactants and the product, and also the mass of the reactants and the mass of the product formed. Likewise, in the second experiment too, you have to write the reactants and the products and also the mass of the reactants and the mass of the products formed. So dears, in the first experiment, in the first case, who are the reactants? Reactants are hydrogen and chlorine. Okay, what are their masses? Hydrogen is 2 gram and chlorine is 71 gram, so which is equal to 73 gram. The mass of the reactants is 73 gram. And who is the product formed? The product formed is HCl. And what is the mass of the product formed? Mass of the product is equal to 73 gram. That we can encounter here. The mass of the product formed is 73 gram. Likewise, in the second experiment too, who are the reactants? Hydrogen and chlorine, and the mass of them is 4 gram and 142 gram. So totally very good, 146 gram. And the product formed is HCl again, and the mass of HCl formed is 146 gram. So what can we infer from this? Yes, of course, the total mass of the reactants and the total mass of the products are always equal. The total mass of the reactants and the total mass of the products are always equal. So let us consider another experiment, another example. So dears, I have provided you some activity cards. You have to complete that activity card. So the problems for you in it are, we have the reaction between hydrogen and oxygen, between hydrogen and oxygen, and the product formed is water. The product formed is water. Okay, in the first experiment and in the second experiment. Okay, in the first experiment, what is the mass of hydrogen? 2 gram. Okay, 2 gram. And you have to find the mass of the oxygen, and you have given that mass of water formed is 18 gram. And in the second experiment, you have to find the mass of hydrogen, provided that mass of oxygen is 80 gram and the mass of water formed is nothing but 90 gram. Okay, how to calculate? It's very good. We know that total mass of the reactants and the total mass of the product are always equal. So in this case, who are the reactants? You have to write it down on the activity card provided to you. So the reactants are hydrogen and oxygen. So the reactants are hydrogen and oxygen. The product formed is water, of course, water. So in the first case, so while adding the masses of hydrogen and oxygen, we must get the mass of water, and here the mass of water is 18 gram. Very good. So 2 gram hydrogen must combine with, very good, 16 gram oxygen. Then only we will get 18 gram of water. And what about in the second case? We have 90 gram water. So 80 gram oxygen must combine with, very good, 10 gram hydrogen to produce 90 gram water. So dears, what we can conclude from here is that in any chemical reaction, in any chemical change, the total mass of the reactants will be equal to the total mass of the product, which means the mass is neither increased nor decreased. Am I right? Yes. Since the mass of the reactants and the mass of the product are equal, there is no change occurs in the case of mass. In mass, so mass is neither increased nor decreased, it remains the same, and this is known as law of conservation of mass. So dears, what is mean by law of conservation of mass? In a chemical reaction, mass can neither be created nor be destroyed. Mass can neither be created nor be destroyed. This is known as law of conservation of mass. So once again, mass can neither be created. Mass can neither be created nor be destroyed. This is known as law of conservation of mass. This is known as law of conservation of mass, and this law is proposed by the great scientist Antoine Lavoisier. Proposed by Antoine Lavoisier. So Antoine Lavoisier has proposed this law of conservation of mass, which states that mass can neither be created nor be destroyed in a chemical reaction. Okay, so have you got it? What's mean by law of conservation of mass? So in any chemical reaction, the total mass of the reactants will be equal to the total mass of the products. Okay, so let us watch a video of a reaction between magnesium and oxygen. So dears, have you watched that video? Yes, very good. What have you observed? Yes, magnesium combines with oxygen, it burns and a white powder is formed. Okay, so a white powder is formed. Okay, do you know what actually that white powder is? It's nothing but magnesium oxide. The white powder formed is magnesium oxide. The white powder formed is magnesium oxide. So yes, shall we write the chemical equation for this reaction? Okay, so magnesium combines with oxygen and forms magnesium oxide. So this is the chemical equation for the reaction. Okay, now let us calculate the mass of the reactants and products here. Okay, so what is the mass of atomic mass of magnesium that you know? Very good, 24 gram. What is the molecular mass of oxygen? Of course, very good, 32 gram. And the mass of magnesium oxide is nothing but 40 gram. So let us consider whether law of conservation of mass is applied here or not. What is the total mass of the reactants? 24 gram plus 32 gram. Okay, so 24 plus 32 we will get 56 gram. So what is the total mass of the product here? It's 40 gram. So is law of conservation of mass is applied here, is applicable here, is followed here? No. How is it possible? We know that in all chemical reactions, the total mass of the reactants and the total mass of the products are equal. Then what happened here? Yes, very good. So here something differs. So I have provided you some other activity cards too. You have to fill those activity cards too. So what's the first question for you there? Okay, which are the reactants in this reaction? Okay, let me rewrite it. Let me rewrite the reaction. Okay, so our reaction is magnesium plus oxygen gives magnesium oxide. Which are the reactants here? Reactants are magnesium and oxygen, and the product formed is magnesium oxide. The product formed is magnesium oxide. Okay, what's the next question? Very good. How many magnesiums are in the reactant side? In the reactant side, we have one magnesium. What about oxygen? In the reactant side, we have two oxygen. Very good, because O2. O2 means there are two oxygen. Then what's the next question? Very good. In the product side, how many oxygens are there? In the product side, we have again one magnesium. And the next question, okay, in the product side, how many oxygens are there? In the product side, just look at here, how many oxygens are there? One oxygen. So is there any change, any fluctuation can you observe? Yes, of course. In the reactant side and in the product side, the number of magnesium is same. One in the reactant side and the same one in the product side. But what about oxygen? In the reactant side we have two oxygen, but in the product side we have only one oxygen. So the number of oxygen is not same in the reactant side and also in the product side. So that's why the total mass has been differed in the reaction. So what we have to do, it's very good, we have to clear out the total number of oxygen atoms. We have to make equal the total number of oxygen atoms in the reactant side and also in the product side. So just look at here how I am going to clear it. So in the product side we have only one oxygen. So in order to make it 2, what we have to do? Yes, we have to take it 2 times. So I am providing 2 in front of it. So now how many oxygens are there? 2 oxygens. Yes, very good, very good, very good. Because I have put 2 here, we have 2 oxygens at the same time. We have 2 magnesium 2 here. It's very good, Arjun. So we have 2 magnesium here, but how many magnesiums are in the reactant side? Only 1 magnesium. So in the reactant side we have only 1 magnesium. So what we have to do? Very good, we have to put another 2 in front of magnesium. So now just look at there, how many magnesiums are in the reactant side? 2. How many in the product side? 2. How many oxygens are in the reactant side? 2. How many oxygens are in the product side? 2. Now let us calculate the masses. So 2 magnesium is equal to 48 gram. O2 means 32 gram. Okay, and magnesium oxide, the 2 magnesium oxide means 80 gram. So now just check it out whether the total mass in the reactant side and the total mass in the product side are equal or not. Yes, of course, the total mass in the reactant side and the total mass of the products are equal. Thus, the law of conservation of mass has been verified here. So, yes, in this manner, making the reactants and the products, the same atoms in the reactant side and the product side to be equal is known as balancing the reaction. So now we have balanced reaction, and this reaction is known as the balanced chemical equation. This reaction is known as the balanced chemical equations. So balancing a chemical equation means making the number of atoms in the reactant side and in the product side equal, the same atoms, the number of same atoms in the reactant side and the product side it must be same or equal, and making this is known as balancing the chemical equation, and the reaction obtained in such a way is known as the balanced chemical equation. So yes, today we have learned many things. We knew about changes are of two types, namely physical changes and chemical changes. In a chemical change, a chemical transformation occurs. A compound has been transferred into another compound. So chemical changes are observable in everywhere in our surroundings. So in any chemical reaction, in any chemical change, the total mass of the reactants will be equal to the total mass of the products, which means mass is neither increased nor decreased, or in another word, mass can neither be created nor be destroyed, and this is known as law of conservation of mass. And who proposed it? Very good, Antoine Lavoisier. And finally we dealt with how to balance a chemical equation. How to balance a chemical equation. So now you are thorough about balancing a chemical equation. So dears, let me give you a follow-up activity. You have to complete it. Okay, so the reaction for you are, just look at here, N2 plus H2 gives NH3. You have to balance this reaction. In the same way, H2 plus O2 gives H2O. You have to balance this reaction also. So just try to balance all these reactions and submit it tomorrow. So dears, take much care and study well. Let us meet in the next class. So until then, it's bye. Thank you.